Hi everyone, let us start with algebra exercise 3.3 and question number 7. So determine whether x minus 1 is a factor. So here we are going to factor. Still we have seen remainder theorem. Now we are going to see a factor theorem. Factor theorem is simply can be written as if x minus a is a factor of p of x, p of a is equal to 0. In remainder theorem, this is the remainder, right? Here they are saying P of A is equal to 0 means then x minus A is a factor, or x minus A is a factor means P of A is equal to 0. So this is what we are going to use here. Here they have asked to check true or false, like determine whether x minus 1 is a factor of the following polynomials. So let us start our first solution. The first one is, let us take it as p of x. Okay, so p of x is equal to x cube plus 5x square minus 10x plus 4. So this is our given polynomial, and you have to check whether this polynomial has a factor x minus 1. So as per the factor theorem, what you have to do, if x minus 1, if suppose is a factor, then first of all equate it to 0 to find your value of x. X is equal to 1, which means your p of 1 should be equal to 0. So we have to verify this. We have to verify whether this p of 1 is equal to 0. So let us take our LHS. LHS will be p of 1. So p of 1 means P of 1 means you have to put 1 in all the places of x. So let us start. That will be a 1 cube plus 5 times of 1 square minus 10 times of 1 plus a 4. Okay. So now what happens is 1 cube is nothing but 1. And 5 times whatever happens with 1, we know it is 1 only. So we can directly write it as 5 because this is positive, you don't have to worry. Else we have to check the symbol. Minus 10 into 1 is minus 10 plus the 4. So now if you could see, this is 1 plus 5 is 6. So 6 and this 10 minus 4, that can be as such, or you can write the answer also 10 minus 4 plus 4. So now what happens is this 6 plus 4 is equal to 10. 10 minus 10, which is equal to 0. Or you can directly write here as 0 if you are very good with maths. 1 plus 5 is 6. 6 minus 10 is minus 4. Minus 4 plus 4 is 0. Anyways, we have arrived at a conclusion. P of 1 is equal to 0. So our LHS is equal to our RHS. So if you come to a conclusion P of 1 is equal to 0, x minus 1 is a factor of P of x. So we can write it as, for the first polynomial, we have verified that x minus 1, yes, it is true, x minus 1 is a factor of P of x. So let us move on to the second one. This is done. The first one is done. So do remember, just equate this to 0 and then find the P of that x value. If it is 0, then it is a factor. Okay. Now let's move on to the second part of this question. The second part of this question is, let us take g of x is equal to, you can take g of x, h of x, f of x, anything, okay? G of x is equal to x power 4 plus 5x square minus 5x plus 1, okay? Now here also you have to check whether x minus 1 is a factor. So let us equate it to 0 to find your value of x, which is x is equal to 1. So factor means what you have to do? You have to get this value as equal to 0, which means your g of 1, you have to check whether it is coming as 0. So let us find our g of 1. G of 1 is nothing but every x put it as 1. 1 power 4 plus 5 times 1 square minus 5 times of 1 plus 4. Okay. So what happens here is, then 1 power 4, 1 power anything is 1 only. Since it is a positive 1, don't worry, put it as such. 5 times 1 is also 5. minus 5 and the plus 1. So here if you could see this minus and plus 5 will get cancelled. Do it carefully. It might seem easy but sometimes you might go wrong. So then what means 5 minus 5 is a 0. And 1 plus 1, what is 1 plus 1? 1 plus 1 is a 2. So be careful, you have got your g of 1 as 2. Don't put it as 1 plus 1 is equal to 0, you'll end up wrongly. So which is not equal to 0. Which means your x minus 1 is not a factor of, is not a factor. Don't put the symbol, just write it like not a factor. Factor of g of x. So previously the first question is a factor because we got 0. This question is not a factor because we can get the g of 1 as 0. So this is the conclusion. Hope you understood this question. Factor theorem, do apply it whenever you get the term factor, and remainder theorem apply it when you get the value with the word remainder in your question. Okay, thank you for watching. And this is exercise 3.3, question number 7.